Okay, hello students, welcome to our lesson on index laws. Now we've used index laws with numbers before, but we're just going to express the same principles algebraically. So you should be familiar with these index laws, but they'll look just a little bit different. So the goal for today is that you'll be able to use index laws to simplify algebraic expressions with positive indices. Now, key ideas are that index laws can be used to simplify expressions involving terms written in index form. Now, the index laws for multiplying or dividing terms in index form only apply when the bases are the same. Now, the term x is in the index form is x to the power of 1. Any base raised to the power of 0 is equal to 1. So, a to the power of 0 is 1. So, let's just remember this. So, x to the power of 0 equals 1. X to the power of 1 equals x. X to the power of 2 equals x times x. X to the power of 3 equals what? X times x times x. Now let's have a closer look at these index laws. So if we say any number, or a number raised to the power of m multiplied by the same number raised to the power of n, is that number to the power of m plus n. Now the next one is any number to the power of m divided by that same number to the power of n equals that number to the power of m take n. Now the next one is any number to the power of m in brackets to the power of n equals what? That number to the power of m times n. Now, a times b, so any number times another number inside brackets to the power of m equals the first number to the power of m multiplied by the second number to the power of m. And then in brackets, any number divided by another number in brackets to the power of m equals that first number to the power of m over the second number to the power of m. So let's just recall, first of all, just our index laws, how we saw them last unit. So for example, 3 to the power of 4. And what do we want to do? So 3 to the power of 4 times 3 to the power of 2. So what we do is we add the indexes and keep the base the same, don't we? So that's like saying 3 to the power of 6. So remember, 3 to the power of 4 is 3 multiplied by itself 4 times, multiplied by 3 multiplied by itself 2 times. So if I want to think of it in expanded forms, 3 times 3 times 3 times 3, that's this bit here. Then I'll just put the times there and then 3 times 3. And so you can see that this is also like saying 3 to the power of 4 plus 2, which is 3 to the power of 6. Let's have a look at this one. 7 to the power of 8 divided by 7 to the power of 5. Now, the working I just want you to show is 7 to the power of 8 minus 5, and that should equal 7 to the power of 3. Likewise, the next one, 2 to the power of 3 in brackets to the power of 2. Remember, that's this rule where we just multiply them together. So 2 to the power of 6. You can have a look at that in more detail in the expanded form if you like. Let's have a look now. So we're going to just apply the same rules, but in this case we have a pronumeral as the base. Remember, a pronumeral is just a symbol that represents a numeral. So in this first case, it's the letter x. So our working here is x to the power of 6 plus 3 equals x to the power of 9. This one is x to the power of 5 take 2 equals x to the power of 3. And then what's this one? It's x to the power of 4 times 3, and that's x to the power of 4 3s is 12. There we go. Now let's have a look at this one. We're using index laws to simplify expression. So this time we're going to, first of all, multiply the coefficients. So 2 times 3 is 6. Now we're going to go 6. And then we've got 7 plus 4 is 11. So 6x to the power of 11. Let's have a look at this one. So remember, we set this one up as a fraction before we do this. So we go 8x 9, 12x 5. So we can simplify through, divide both the top and bottom by 4. So that's going to be 2, that's going to be 3. Now x to the power of 9 divided by x to the power of 5 is going to be x to the power of 4. So I can just go that and cancel that and go like so. So I can go 2x to the power of 4 over 3. Now I can express this a couple of different ways. So I'll have a look at that with you in class in particular. But let's see what it says down here. Yep. So it's just broken that up down there, and that's then x to the power of 4. You can write this a few different ways. So you can just say 2/3 times x to the power of 4, or 2x over 3 to the power of 4 as well. So let's have a look at this next one. So we're starting to get a bit more complex, aren't we? So now we have x to the power of 3. Now it's 3 times 5 times x to the power of 2. So I'm going to just do a couple of lines working. Well, 3 5s are 15, and plus 2, so that's x to the power of 17. Now you're going to have a bit of fun with this one. You can see that I can attack it a few different ways, but what's the first way to do it? I think I'd solve at the top and then I'd cancel through and do the bottom. And there's a couple of different ways. First of all, for example, I can just go straight away and do that, and I could go there. That's 4 now, and that's 1. Oh, and this is a little bit harder. So that's a 4 and that's a 3. I could go, oh well, let's put that as a 2, and then I've got x to the power of 3 times 3. So what I might do is just take it back a few steps and do the top first. So there's a few different ways to attack this. So 4x to the power of 8. Oh, well, let's go 4 times 3 is 12. So for 12. Now, x to the power of 8 times x to the power of 5. Well, that's what? 8 plus 5. And then let's do this. Now, that's just remember, if you don't see any number in front of a pronumeral, it's just a 1. So 2 times 1 is 2. Now, x to the power of 4. Now, this is, remember, x to the power of 3 times 3. Let's work on this now. So we've got 12x to the power of 13. And then 2. Okay, so that's x to the power of 9 there, and that's x to the power of 13. Oh, far out, they just simplify through. X to the power of 13 divided by x to the power of 13 is 1. That's nice. 12 divided by 2 is 6. So the answer is 6. Did I get that right? Oh, it's got 6 to x to the power of 0. And x to the power of 0 is 1. Yep, so that's fine. Okay, so copy down the notes. Have a go at this literacy one here. And then I'd like you to get working on your mastery exercises, please, students.